This is part 1 of the Chapter 12 review, and the review starts out with 3 solids of revolution. That is, 3 solids formed by rotating a figure about an axis. Number 1, we have a triangle rotated around a vertical axis. Now, it may be difficult to visualize these things. If you were to rotate this, say, counterclockwise, or from left to right, or clockwise, depending on how you're looking at it, this would form a cone. So in case it's difficult to visualize this, let me try a different approach. And here we have a vertical axis with a triangle attached to the vertical axis. Now I'm going to go ahead and rotate this in increments just to show you what's being formed here. Now here we have the bare triangle, and we'll just do a little rotation here, and you can see that what we're forming is a three-dimensional solid, and if I keep rotating it, we will have a complete cone. So that's a solid of revolution. Now you could also try sketching this cone, and it's probably not a bad idea to try and develop some rudimentary sketching skills if you're not an artist. I am by no means an artist, so it's very difficult for me to sketch these things, but it's always good to be able to visualize your problem if you're a visual person, which I am, and if you're a visual learner, that might help. So here I have a secondary version of that triangle, and if I try to sketch this, see if I can do this. This, of course, is hidden line removal. And if I put in the triangle here, and you can see really bad line there. Let's try that again. There we go. And so we have this rudimentary three-dimensional cone shape. All right. Now for number 2. In number 2, we have this semicircle. And it's a semicircle with a radius of 7. And if we rotate this, let's say going away from us, from front to back, I think you can see that it would generate a sphere. So let's go ahead and take a look at that from a different perspective. Here we have the semicircle, and if we want to rotate that away from us, we would generate something that starts to look like that. And you can see that we have kind of hemispherical shape here. And if we continue and close the figure, you can see that we have a nice little sphere here. And back to the original. Again, if we wanted to sketch this, we would draw in another semicircle here. So let's give that a shot. Alright, don't laugh. And we draw in this piece here and this piece here. So, see how good you can draw your little sphere. The idea is it doesn't have to be perfect, but it just has to give the visual impression of the three-dimensional solid you're looking for. And here we have a sphere with a radius of 7. Now, for number 3, we have a quarter of a circle here and a triangle. Now, if we rotate this about a horizontal axis, you can see that this bottom part should generate a hemisphere, and the top part would be a cone. So let's try to visualize that. And here we have our little quarter circle with our triangle on top. And if we try to rotate this, so we have the raw shape. Let's go ahead and rotate it a little bit, and you can see that it's forming a hemisphere on the bottom and a cone on the top. Alright, now back to the sketch, And again, we can give it a shot and try to sketch this thing. Now this one's going to be extra hard because we've got two shapes. So let's see if we can get a hemisphere drawn in here, or part of a circle down here. Alright, and then a triangle here. And then extend this seam, and this is going to come out like this and back that way, and something like that. Not very good, but I think it gives you the idea. It doesn't look as good as the other one did, but again, it gives a really rough idea of a three-dimensional figure, enough to be able to solve a problem, seeing that this has a radius of 8, so this is a radius of 8. Alright, so that's solids of revolution as such that it is. Let's move on to problem 4. In problem 4, we're being asked to describe the cross-section formed by the intersection of the plane and the solid. So think of a cross-section as a paper-thin slice of a three-dimensional solid. In this case, we're slicing it parallel to this bottom face, and since that bottom face is the shape of a rectangle, as we move up from the bottom to the top of the shape, you can see that the cross-section, this piece right here, this dark shaded piece, is going to be a rectangle. Now if we were to rotate this plane so that it would be parallel to this front face, then I think you can see that the cross sections would be pentagons, and they would be consistent in size since these pentagons are congruent and parallel. Alright, problem 5. Here we have another plane that's parallel to the base going through this pyramid, and that plane is clearly going to form a cross-sectional shape of a square because the base is a square. And then in this one we have a plane parallel to the bases again. This is a triangular prism, so clearly that is a triangle. So hopefully this isn't too terribly challenging. You just have to use your visual acuity skills and try to imagine what this would look like if you sliced in different ways, because you won't always be given a nice clear picture of this. So it might not be a bad idea to exercise your skills. Rotate this 90 degrees so that this plane, this cross-sectional slicing plane, is parallel to the base. Can you see what that would be? Since this piece is a rectangle, as we moved up through the triangular prism from bottom here to top here, it would be a rectangle with decreasing width, but the length would be the same. Alright, so that's problems 4, 5, and 6. Let's move on to problem 7. In these three problems, we're being asked to find the lateral area and the surface area of the right prism or right cylinder. So here we have a cylinder, and lateral area is the area of the lateral faces. So it's the curved surface here of the cylinder itself without the bases. And we know from our study of nets that the net of this cylinder, this curved surface, is actually a rectangle, and the width, or I should say the length of the rectangle, is the circumference of the base. So let's begin here. We know that lateral area is equal to circumference times height. Circumference is 2 pi r and times the height. We have a radius of 4 and the height is going to be 18. So this is 2 pi 4 times 18. We put that in our calculator, and that is, let's get these equal signs in here, that is 144 pi as the exact value, or the approximate value, for 52.4. So that's the lateral area. Now the surface area is lateral area plus 2 times area of the base. And we know that the area of the base is a circle. So the area of the base is pi r squared. So that's pi 4 squared. And then we can put all that in down here. We have lateral area, and I'm going to use lateral area here because I'm assuming that you're storing this lateral area in your calculator so that you don't lose any precision, plus 2 times pi 4 squared. Let's go ahead and put that in our calculator, and we will get an approximate value here of, before we write this one, let's go ahead and write this one. This is going to be 16 pi, which is approximately 100.5. And so when we add this and multiply it by 2 to the lateral area, we get 552.9. Let's go ahead and move on to problem 8 now. For problem 8, we have this triangular prism, and we're going to have to find the areas of all 3 of these rectangular faces, these lateral faces. That'll give us our lateral area. And then, after we've found those, we will find the area of these triangular bases. So first, let's do this one. That's the most prominent one to me. Since this side is congruent to this, we have 17 by 20. Lateral area is 17 by 20 plus 16 by 20 plus 17 by 20. Now you could, if you want, go in and use the formulas that are in the book for perimeter times height, but I choose to do it a little bit more brute force just so that I don't miss anything and just so that I can see the lateral area forming for me. This gives us 340 plus 320 plus 340, which is 1,000. Now our surface area is going to be lateral area plus 2 times area of the base. Now our job is to find area of the base. Area of the base is a triangle, so it's 1/2 little b, which is the base of the triangle, times the height of the triangle. Now if we take a look at this triangle, what we have here is we have an isosceles triangle, this side being 17, this side being 16. So because this is isosceles, this altitude is bisecting the base, so that makes this an 8. And you could go ahead and use Pythagorean theorem, or you could see that this is one of the more seldom used Pythagorean triples. This is an 8, 15, 17. Pythagorean triple, so this is 15. That makes this 1/2 base 16 times the height. This piece is 15. That gives us 120. So we're going to have 1,000 plus 2 times 120, which comes out to 1240. Just to recap real quick here, lateral area is the area of the faces that aren't bases. That was this. Surface area is lateral area plus the area of the bases. And in this case, we had 2 bases that were triangles. So we found the area of the triangle and then added them in. That'll wrap it up for this segment. We'll cover problem 9 and beyond in the next video. So I'll talk to you then.